the idea was, you've got to receive on television, in the days when we transmitted radio signals over the air instead of delivering them by cable. In some cases we still do, but not as much. You had to cover a span from channel 2 to channel 83, even if the channels above 70 were not used. And that's a span from 54, bottom edge of channel 2, all the way up to 890, which is the top of channel 83. Oh boy, that's a long. How do you keep an antenna resonant at all those frequencies? You come up with a clever design. So what they did with the log periodic is they had a series of elements that were spaced in length so that one would radiate at a time, and when you receive a signal at a different point that was higher in frequency than this one would, the next shorter one would pick up the slack, so to speak. They would all contribute to it. They did that by staging the lengths and spacings so that they were logarithmic, meaning they were according to orders of magnitude, not so much actual multiplications of numbers. We're going to talk about that next week when we talk about the decibel. Not next week, but next time, which is the 23rd, did I say?
26th.
22nd, just before Thanksgiving. A decibel, something we've all heard of. You know, you're yelling and you're at 90 decibels, my ears are splitting. Decibel has a technical definition. Oh, that's pretty much it. It's a relative measurement. Relative meaning how much greater is this than that. This is maybe your input to an amplifier, voltage 1. Your output is voltage 2. How much gain did you get going from this point to this point? Well, you take the output, you divide it by the input. Okay, maybe that number is 100. Typical. You take the base 10 log. What is a logarithm? I'm always bringing up your high school math days, right? You're going to say, don't do that. I hated that subject when I was there. Okay, here's what you missed when you weren't paying attention. I forgot. So you did pass the course. If x raised to some power p equals something, let's say some value n, I'm just picking these letters. There's nothing sacred about those letters. I don't even know if they should be. I'm embedding them. If you take a number and you raise it to a power, and you get a big number by raising it to the power, like for instance, if this number x is 10, and you raise it to the second power, 10 squared is 100, 10 times 10. 10 cubed is 1,000. 10 times 10 times 10. What if I want to multiply 100 times 1,000? Oh, God, I gotta do this thing. I gotta have 1,000 here, and I could put 10 here, and I put the 0 here, and okay, 10,000. Makes sense. 10,000 times 10 is 10,000. Or I could say I got 2 zeros here. Interesting that that happens to be what that number represents. And I got 3 zeros here. And I just add them together, and I get 10 to the 5th. What's 10 to the 5th? Something with 5 zeros. I'm sorry, something with, yeah, 100,000. That's what I'm doing. So 100 times 1,000 is 100,000. 10 times 1,000 is 10,000. Same thing applies here. This is 10 to the 3rd times 10 to the 1st. Add the 2 together, and you get 10 to the 4th, which happens to be what that number is. If you add the exponents, you're multiplying numbers. So the guy that came up with the logarithm process said, let's take a thing called this, and we'll call it the base of the logarithm. Well, since we're in a system that is decimal, uses the number 10 for its base, base 10 logarithms make sense. Now, what I do with every number that I got out here, if it's 10,000, I just ask myself, what exponent will get this, what power of 10 equals that? Well, we know that that power of 10 happens to be, how many zeros are in the fourth power of 10 is 10,000. The logarithm is that. The base 10 logarithm is the exponent that gives you that multiplier using that base. Why do we do that? Well, because we want to multiply things together, but we want to do it the easy way. And when you have logarithms, if you add the logs together, you're really multiplying. So I got a 100-watt transmitter, and I've got an amplifier that gives me another multiplication of something. I don't care what the multiplication is, I want to know how many dB of gain it has. And I got a transmission line that loses something, so it's got a negative, it's got a dB of loss. Then I got an antenna which has a certain dB of gain for all the reasons I described. All I have to do is add up that list of losses and gains in dB, and I got the gain relative to the transmitter's power. The whole network, they call that the link budget. This, all added together. And that's why we have logarithms. There's another reason we have logarithms, and we're over time, but I'm going to make this real quick. Things that get very large very quickly are very unwieldy to work with. You know, like the old Italian currency, the lira. How much is that? Oh, it's 150,000 lira. That's not so much, you know, might be 20 bucks. Wouldn't it be easier if we worked with smaller numbers? Okay, let's take earthquakes, for instance. A Richter 4 earthquake just happens to be 10 times as powerful as a Richter 3. A Richter 5 earthquake is 10 times as powerful as a 4, 6, 10 times as powerful as a Richter 5. What we are doing is counting multiplications of the number 10. They call that orders of magnitude. When you have any number that you put up here, 321,215, you know, whatever it is, that is 10 to the 0th power, 10 to the 1st, 10 to the 2nd, 10 to the 3rd, 10 to the 4th, remember, 10,000, this is 10 to the 5th. It is 5 times 10 to the 0, and 10 to the 0 is always 1. 1 times 10, 2 times 10 squared, 100, 1 times 10 cubed, 1,000, 2 times 10 to the 4th, 10,000, 3 times 10 to the 5th, 100,000. So it's 300,000 plus 20,000 plus 1,000 plus 200 plus 10 plus 5. If you add all those numbers together, that's the number. Orders of magnitude are what you deal with every day in the number system. You just don't necessarily look at it that way unless you took the right math course and somebody drilled it into you. Which, fortunately, was my reason for doing that. We're going to talk about that because decibels will be on the test too, and you have to kind of learn a little bit about how to deal with it. But that's the basic idea. We use exponents instead of the actual number because they're not as big, and if you want to multiply them, just add them together. Voila, up come the answers. So they don't have to be even numbers like 2, 3, 4, 5. They could be 1.6, something like that. And you can raise things to the 1.6 power. Try it on your calculator sometime. Or if you have an old math book, look up the table of 5-place logarithms, and it will show you for every number there is what the logarithm for it is. Take this number, get the log. Take this number, get the log, add them together, and take the anti-log. Figure out what that added log is, and it's like you just multiplied the two numbers. That's, by the way, how your calculator does multiplication. It adds logarithms. If you had a slide rule, you were adding logarithms, and you could multiply the C times the D scale. If anybody's here is old enough to remember slide rule, aha, there's one. That's how we did it. It wasn't just for being a back scratcher. All right, guys, we're going to meet on the 22nd. I'm going to 26. I'm sorry, never get it right. I'm going to try to figure out what I didn't cover that I meant to, and cover those things. I'm going to probably use the session after that to cover problems in the question pool. You can go at the DRR website, or send me an email. If you can't find it, I'll email you the question pool, and that's the stuff you have to know the answers to get through the test, and then you'll know exactly where you stand. You will know you're gonna pass or fail depending on how you handle the answers to the question pool. So isn't that convenient? This is a case where you know what your test is gonna be like long before you see it. All you have to do is prepare for it. The way to prepare for it is to read the book if you have it, or just look at the questions and see how well you can fathom them from the answers from all the stuff I've given you. And when you can't, bring me the questions and I'll work on them with you. That's what we're going to cover in the second to last session. The last session is the test, December 10th. Anything else? Call me, email, write me. I'm very accessible, but not for the next 10 days. I'll be crazy. I'll answer emails. I'm going to bring my laptop. I always do because so I stay in contact with the world. So you might catch me in a moment where I can actually answer your question from halfway across, not halfway, but 8,000 miles, 4,000 miles away, whatever it is.
Yeah, we'll just get it at 4 o'clock in the morning or 3 o'clock.
I'll answer it when I'm awake. That's the nice thing about internet. It's stored forward. I don't have to be there when the moment it shows up. Give you the answer. I'll just do it when it's convenient. And by the way, in ham radio, we have similar things. We have packet radio, which essentially says, let's take your computer and attach it to the radio spectrum the same way you do it with the phone line. Use a modem. Packet radio was this taking of X.25, which is the basic protocol the internet uses for putting its packets together, and directing it through the radio spectrum rather than through phone lines. And we used to communicate, this has been very popular in the 70s. We used to send emails and such to everyone. And some of us even had IP addresses that were assigned to us individually if you wanted to do the advanced kind of node management things. It kind of died out because the internet came along and kind of took away all their thunder, but we were pioneering in this stuff. Most people were not using the internet. Think about it. When did the internet really become popular? Mid-90s. That's when the World Wide Web existed. You had Mosaic and Netscape and all those tools. And the cost of getting on the internet wasn't so prohibitive. I remember when Northwestern said, we'll sell you access to our system for $30 a month. Well, that was a lot of money. But CompuServe had a very basic system for about half that.
Or ArcNet, or
ArcNet, yeah.
bulletin boards.
Yeah, but you had to get an internet service provider that you had the telephone dial into with your modem to get into that process. And CompuServe was there, and they had those addresses that were a number, a dot, and another number.
Why did we have zip files?
Because we want to save time
Long
transmitting,
distance
receiving
phone
stuff.
calls.
Hardly anybody zips anything unless they want to keep things below the
Yeah, but
typically
we had
10
a long
megabyte
distance
limit
phone
that you
call.
have for attachments for.
You were paying long distance to get a hold of a bulletin board.
Yeah,
So
that's
you
right. The
zipped
cost of
zipped
time,
it, so you
connect
didn't
time.
have to have the long distance charges.
It would change your download time. You're right.
Yeah.
Zipping isn't very popular anymore because, if you have a really huge file, you just get Dropbox. You
Yeah.
load it into that or have an FTP site. How things have changed. I remember the time I called my phone company. I said, okay, this is ridiculous. The landline bill's going up and up. And I can't even make a long distance call. I have to use my cell phone for that. Oh, sir, why didn't you ask us a long time ago? We'll give you any time, anywhere, minutes, for the same low price. Thanks for not telling me until I asked. Bastards. So I got that on my landline. Now, why do I have a landline? A lot of people are dumping that because if you've been around lately, 90% of the calls on your landline are, hi, this is the XYZ party. We want you to go out and vote on Tuesday. This way, answering machines were invented. You look at the caller ID and it says Ohio call, Washington DC call. You're not going to answer that one. Twice, some charity. Talk to my machine. That's why I guess everybody seems to be trending toward wireless and forgetting about the landline, but I guess they're useful for some things. I'm still attached to them and so on, but they're starting to die out. I think countries that have more wireless than landlines, Finland was the first one like that, and others are catching up like us.